We're going to start talking about acids and bases by talking about electrolytes. If you remember, electrolytes were those ionic compounds, generally ionic electrolytes, that when dissolved in water, they created ions. And because they create ions, they could conduct electricity and therefore, in this case, light a bulb. Therefore, it means that we were able to identify how the ionic compound splits into a positive and a negative part, and this is why they were electrolytes. Good. We opposed electrolytes that are typically ionic compounds. We oppose them to the covalent compounds which in water they do not conduct electricity because water is not strong enough to break covalent bonds, or it's not cannot stabilize the breaking of the bonds as it can do in ionic compounds. So typically a covalent compound in water will not create ions and will not conduct electricity. However, there is, as in chemistry it's typically the case, there is an exception, and one of the exceptions is acids and bases in water. An acid or a base in water will be, typically they are covalent, but some of them are also ionic, that will release some either H+, what we call them protons, or hydroxides in water. So this means that even though, like, hydrogen chloride is a covalent compound, it releases H+ in water. Therefore, you will see that solutions of acids and bases, even though they are mostly covalent compounds, they can conduct electricity because they have ions. Of course, sodium hydroxide, in this case it releases OH negative. It's already an ionic compound, but it behaves like a base, as we will define in just a few seconds. So, talking about that, what is a base? What is an acid? The oldest definition is the Arrhenius definition, in which he defined an acid as a substance that produces H+. Again, we'll keep insisting. We'll call H+ protons. Remember that a hydrogen is one electron and one. That's a hydrogen, right? One proton and one electron. If you remove the proton, what you have left is only the if you remove the electron, what you have left is only the proton. This is why H+ is called a proton. Okay, so an acid is a substance that that produces H+. To be fair, sometimes the proton, the H+, is not free. It's actually combined in water. So this, we call this the hydronium ion. Okay, so in that perspective, we should write the above equation as such. Okay, notice these two are equivalent, they are the same. In one of them you explicitly write the water, in the other one you do not. Okay, so what is a base? Based on the Arrhenius definition, a base is a substance that produces the hydroxide ions. Okay, so in this case it just produces hydroxide ions. There is a more recent, still old, but more recent definition, which is the Bronsted-Lowry. It's an O with this symbol here. The Bronsted-Lowry definition defines acids and bases not for what they give, but for what they do. So an acid is a proton donor. So in this case, as we wrote, the HCl, hydrogen chloride, or hydrochloric acid, we should say, when it's dissolved in water, gives the proton to the water. Okay, and a base will be a proton acceptor. Okay, so in this case, notice there's no OHs, and this is why the Arrhenius definition wasn't good enough, because you cannot see any OHs in here. But if you think ammonia as having this lone pair that can accept one of these protons, therefore you will have the ammonium ion, and again it will create hydroxides. What are the characteristics of any acid-base reaction? There is no acid without a base, and there is no base without an acid, because if an acid is a proton donor, the acid needs to give the proton to a proton acceptor, and likewise, if a base is a proton acceptor, it means that there is another species that is giving the donor. So the acid and base always go together. So, and the base will become what we call a conjugate acid, and the acid will become what we call conjugate base. Okay? And all acid-base reactions will depend on the capacity for an acid to give the protons and the capacity of a base to accept them. So let's practice a little bit. In this case, if we're giving you a list of reactions and we are already identifying them as acid and base. However, it's important that you can identify acids and bases. We'll give you a list for you to memorize because some of these problems rely so much on memorizing what's an acid and what's a base that it may be convenient to memorize. In this case, hydrogen fluoride is an acid and water behaves like a base. So this will hydrogen fluoride will give the proton, therefore it will remain as F negative, and water will accept a proton. So this will be the conjugate acid. Notice that the base becomes a conjugate acid and the acid becomes a conjugate base. Okay, so let's keep doing these. Formic acid, let's make sure we understand what this is, right? This is a formate, gives the proton, and will form the cyanhydric acid. Okay, that's important. Ammonium ion with carbonate, this will become ammonia, and if we add enough, notice that in this case there was just a transfer of one proton, just one. In this case, however, carbonate can accept up to 2 protons. That will make it carbonic acid. Therefore, it means that I need 2 ammonium ions because I need to provide 2 protons. In this case, the hydrogen phosphate acts like an acid. It could act like a base depending on the capacity of the partner. In this case, definitely OH negative is a base. That means it will accept 1 proton, and this will release 1 proton. So what we have here is this 2 negative. If we're going to do the same as before, notice that this can give up to 2 protons. So let's make sure then that this will create, you need 2 of these, and therefore you will have transferred 2 protons the same way that there were 2 protons transferred in here. So you need to make sure that it's properly balanced. Okay. Again, you have the sulfuric acid that behaves like an acid. It can give up to 2 protons, and therefore ammonia, you will need, that's very important that you can practice this. And finally, this is the acid. I'm gonna call this careful because for reasons that we're not going to talk about, this may not be happening. But anyway, notice that following the same trend, this is not going to happen, but we will explain why. You would need 2 protons, and therefore you would need 2 of these, 2 phosphates. Okay, hopefully that will make some sense. We will keep practicing. It's very important that you can draw acids and base reactions.